Alright, and welcome back. In this video, we're going to pick up where we left off in the last one. We're going to actually get to graphing transformed tangent functions. Okay, so remember we went over how to find all this information. I just want to kind of scroll back up here and look at this graph. Okay, now if you notice, this graph is very different than sine and cosine. So I'm going to be graphing these just a little bit different for one full cycle. Okay. Now the pattern here, as you can see, is it starts at the midline. It started right at the midline. So it starts at the midline, which in this case was 0, and then it goes up to the right, and then there's immediately a vertical asymptote, which means if you start at the midline and actually go down to the left, then there's a vertical asymptote on that side as well. I always like getting kind of one full cycle looking something like this. I want to see that full curve. I want to see a bound in between the two vertical asymptotes. So I'm actually going to be going a little bit to the left as well to the right. In other videos, we only went to the right. We only kept adding to scale to go to the right, but I just feel that we don't get as nice of a graph that way. So I'm going to be doing it just a little bit different in these ones. Okay. But we got to remember that tangent starts at midline. Tangent starts at the midline. And it goes up to the right and bound between vertical asymptotes. Okay, I'm just going to say VA. Okay, now let's go ahead and actually try graphing one. So let's do something like, I don't know, let's do something like y equals 2 times tangent of 1/4 x plus 1. And let's find all that information that we normally would find as well. Let's find the amplitude. Let's find the midline. Let's find the period, and let's find the scale for x. Okay, so let's go ahead and find these. Amplitude, well, there is none. Remember, tangent does not have amplitude. Actually, sine and cosine are the only trig graphs that actually have an amplitude. The three reciprocal functions, cosecant, secant, and cotangent, none of them have an amplitude as well. So sine and cosine are very unique in that way. Okay, so there is no amplitude. However, it is being vertically stretched by 2. Okay, so we're going to use that in a fairly similar way that we use the amplitude. Now, this graph has been shifted up 1, which means the midline is y equals 1. Okay, so I'm going to start kind of getting a graph going here. Now, the midline is up here at 1. Once again, you don't actually need to graph the midline, but I like to just for organizational purposes. And there is no amplitude, but it is being vertically stretched by 2. So remember, with sine and cosine, we use the amplitude. We rose up. If, say, the amplitude was 3, we went 3 above the midline, 3 below the midline. We actually do the exact same thing. Even though it's technically not an amplitude, that vertical stretch by 2, we use the same way. So I'm actually just going to go up 2 and down 2 to kind of hit the high and low points that we're going to actually plot with a point. Okay, now the period is always pi over the absolute value of b for tangent. Okay, remember it was 2 pi over b with sine and cosine, but it's pi over the absolute value b with tangent, and this would end up getting us 4 pi, which means the scale, we always, to get the x scale, divide the period by 4, which gets us pi. So I'm going to add pi, so 0 plus pi is pi. Add another pi, that gets me 2 pi. Now normally I would keep going to the right, but we don't get a really nice look at the graph of tangent that way. Okay, so I'm actually going to go backwards and actually subtract my scale. 0 minus pi is a negative pi. Negative pi minus pi is a negative 2 pi. And this is going to be my 4 points. Okay, or I should say 5 points. Alright, now tangent starts at the midline, so I'm starting here at the midline, and it goes up to the right. So as I go to the right, I'm going up 2 because it's vertically stretched by 2, and then there's actually a vertical asymptote. I do want to plot that. So I could keep going to the right, but as you can see, it's going to look a little bit weird, so I'm actually going to go to the left. So if it goes up to the right, it goes down to the left. So I go down 2 to the left, and then I'm going to have my other vertical asymptote. Okay, so this is how I'm normally going to graph tangent. Okay, I'm going a little bit left and right. Now it started right at the midline, so at 0, when x was 0, I was at my midline. Then I used kind of the vertical stretch. I went up 2 to the right, down 2 to the left. That's the pattern here for tangent, okay? A little bit different than sine and cosine. And then I have vertical asymptotes on each side. So now I go along the asymptote, go through my points, and there would be my graph of tangent. Okay, so that's how we graph these tangent functions. Okay, I'll go ahead and go over another couple examples. So let's say we had something like, y equals, let's say negative tangent 2x minus 3. Okay, and let's go ahead and find all that information. Amplitude, well, there is none. Okay, and it's also not being vertically stretched at all, because I don't see like a 2 or 1/2 for vertically compressed at all. But I do see that negative. Now remember, that negative means that we're reflected over the x-axis. Or we're going to be reflected over the x-axis, which is, remember, going to kind of flip our pattern. Okay? So our amplitude is none, but we are reflected over the x-axis. Our midline, well, I got shifted down 3. That minus 3 outside means I'm going down 3. So the midline's down at negative 3. So I can go ahead and start making a graph. 1, 2, 3. So there's my midline. That's my midline. And now there was no amplitude and there's no vertical stretch, which means I'm just going up 1 and down 1. So my scale is just going to be 1. So I'm going to go up 1 from negative 3. So I'm going to be plotting a point at negative 2. And I'm also going to be plotting a point at negative 4 down 1 from negative 3. Okay. Now the rest, I got to figure out the period. Period is pi over the absolute value of b, which is 2. So our period is pi over 2, which means our x scale, I'm taking my period and I'm dividing it by 4, which gets me pi over 8. So I'm going by pi over 8. So 1 pi over 8, 2 pi over 8, which reduces a pi over 4. And you could keep going if you want. That's not incorrect, but I'm actually going to go backwards. Negative pi over 8 and negative 2 pi over 8, which remember is negative pi over 4 reduced. And once you get the hang of this, you can actually kind of start realizing, hey, it's bound in between 2 vertical asymptotes, so I can just go ahead and plot those vertical asymptotes right away. So there's my vertical asymptotes. All right, we start at the midline, which is negative 3. And now normally we go up and to the right, but it's reflected, so we're actually going down to the right, which means we're going up to the left. So it just is inverted looking, okay? So because it was reflected, that's why I went down to the right instead of up to the right. And now I can go ahead, go along my asymptotes, cross through my points, and there is our graph, okay? I'll go ahead and give you guys one more example, and I want you to try this on your own first. Go ahead and feel free to try this on your own. I'm out of room down there, so let me scroll over a little bit. So why not try out this one? Try out y equals, let's do 3 tangent of pi x plus 2. Go ahead and tell me what the amplitude is. Tell me what the midline is, what the period is, and what the scale for x is. You can go ahead and pause the video and try this now. All right, hopefully, honor system, hopefully you went ahead and tried this. Let's go ahead and break this down. So amplitude, remember, there is none, but it is being vertically stretched by 3. It is being vertically stretched. Ooh, that looks rough. It is being vertically stretched by 3. Okay. Now, I sometimes refer to that as almost like a fake amplitude because we use it roughly the same way. So just be aware if I ever say that, you know what I'm talking about. So it's being vertically stretched by 3, so it kind of has a fake amplitude of 3. There is no amplitude, but we're going to be using 3 in its place. Now the midline, well, is +2 outside, which means it got shifted up 2, which means the midline is at y equals 2. So let me go ahead, start breaking this down. The midline is at 2. We're going to say that's 2. And it's vertically stretched by 3. So it's like fake amplitude is 3. So I'm going up 3. 1, 2, 3. So I'm going to be plotting a point up here at 5. And I'm going to be going down 3, 1, 2, 3. I'm going to be plotting a point down here at -1. Okay. Now for the period. Pi over the absolute value of b, which is also pi, and pi over pi is 1. So the period is 1 in this case, which means the scale, divide 1 by 4, and we get 1/4. So I'm adding 1/4, I'm adding 1/4, 1/4 plus 1/4 is 2/4, which is 1/2. And once again, you can continue to the right. I'm going to actually go backwards a little bit, go to the left. So I have it over here. And remember, we are bound by vertical asymptotes on each side if we do it this way, which I recommend. So I'm going to go ahead and plot those vertical asymptotes. You always want to plot the vertical asymptotes. You don't have to do the midline, but you absolutely must do the vertical asymptotes. We need to see that it's bound, okay? And remember, we start at the midline, which was 2, and we go up to the right. This isn't reflected, okay? Remember, it's not reflected, so I'm still going up to the right, and it's vertically stretched by 3, so I'm going to be going up 1, 2, 3, to the right, and down 1, 2, 3 to the left. And now I can go ahead and hopefully yours is a little curvier than mine. Okay, we do want it to be a curve and not a line, but this would be a rough sketch of our tangent graph. Okay, so that is graphing tangent. Make sure that you're practicing this. If you want to check out future videos, I will also be graphing the reciprocal functions and also doing something called a phase shift. Okay, that's a one transformation that we didn't cover here. I'll go ahead and make some videos, so stay tuned for those. Those will be released at some time in the future. All right, but that's graphing our 3 regular trig functions: sine, cosine, and tangent. All right, so keep practicing that. Make sure that we're good with those 3 trig functions.